So all the questions are generally going to look like this. They're going to give you a bunch of figures, starting with figure 1, figure 2, figure 3. What does this dot, dot, dot mean? Continues forever. And what they want to know is first, let's describe the pattern in words, what's happening. Then we're going to create a table of values. Then we're going to do what's called a linear equation. I want to highlight that because that's why it's in this unit. It has something to do with a line. And then we're going to use that equation to figure out how many squares would be in figure 12, what figure would have 106, all these other kinds of questions. Describe the pattern in words. Okay, you want to say what are we starting with and what are we adding to go to each next figure. So the first figure starts with how many squares? 4. So we start with 4 squares. And then add, and all we need to do is really just count. We know there's 4 in the first. How many squares are in the second figure? How many squares are in the next figure? If we kept going, how many would be in figure 4 that we don't even see and we don't even need? 13. Et cetera, et cetera. So how many are we adding to the previous figure?
3.
And add 3 to the previous figure.
Does it matter where you add the 3 to?
Nope, not at all. So let's just mark, we're going plus 3, plus 3, plus 3. The reason this ends up being a line is because we're adding the same amount every single time. That makes what we're going to call a linear equation or a linear function. If we were to add 1 and then 2 and then 3, that would not be linear. If we were to add anything other than the exact same amount, it would not be linear. So that's what makes this a linear equation, is the fact we're adding the same amount every single time. So when the question says describe the pattern in words, that's what they want to know, is what did we start with? What did we do to get every figure after that? Create a table of values. I don't know. I just did it until I ran out of space. I think I have 6 there. 7 maybe. The first row on our table is going to be the figure number. What do you think the second row is going to be? Number of squares. And so let's start with figure 1. We already know from above where we counted how many squares make up figure 1. 4. Figure 2 we had. Dallin, put it away, please. Figure 3 we have. And all we're doing is now extending the pattern. We already talked above 4. We know we would have 13. Let's do a couple more. 5 we would have. Where does that come from? 13 plus 3. Figure 6 would have 19. I usually give about 6 in a table of values. If you gave 7, whatever. If you gave 5, whatever. Less than that, I'd be like, do you really understand the pattern? So there isn't a set amount, whatever. Just show me that you understand the pattern. How are we doing so far? Step 3, or C, is going to be the new stuff. This is called the linear equation. In general, the linear equation is going to look like this. It's going to be the number of squares is on the left-hand side. We're going to have to put something times f, which stands for the figure number. And then we're going to have to add something to it. So generally, it's going to look like this. And what we need to fill in are these 2 question marks, is what's going to go here, what's going to go here. This is called a linear equation. They always look like this. There's a number equals something times a value plus something. And we'll figure out the somethings in a second. Now, I don't really want to put a number sign into an equation. We usually want to put variables. You can use any variable you want, but we tend to kind of represent what the thing is. Number, we're probably going to start with n, because n starts with number. F is standing for figure number. The number that goes in front of the F is always what we're adding to the previous figure. So it's the pattern number, we call it. What did we say above we were adding to each individual figure? 3. So that's always going to be the number in front of the F. We call it the figure number, so it's what we're adding. What we're adding here, we just need to figure out what do I need in order to get each of these patterns. So if I take 3 times 1, what does that equal? But I have 4 here. So what do I need to add to 3 to get 4? 1. Let's just double check it with the second one. If I take 3 times 2, I get, what do I need to add to get 7? 1. If I take 3 times 3, I get, to get 10, I need to add 1. 4 times 3 is, plus 1, 13. They're always going to work that way. So the number in front of the F is what we call the pattern number. It's what we're adding every single time to continue our pattern. The number at the end is how many more we need. How many more we need to get the number of squares. How many more we need to get the number of squares. You don't need to know this till next year, but I think it's really important to mention it now. You can recognize a linear equation in math because it never has an exponent bigger than 1. So when we did exponents last, if we look at this end, we don't see it, but what's the exponent? It's a 1. What's the exponent on the F? It's a 1. That's what makes a line a line. When you go higher in math, you're going to look at what happens when we square things and cube them and all these other things. That's what makes a linear function. A linear function is all the exponents are 1. You don't need to know that, but that's kind of important. Questions so far? What's the purpose of having this little formula? Well, it's to make it easier. If we want to figure out the 12th figure, I don't want to have to calculate this 12 times. I don't want to have to send my table and keep counting by 3 and by 3 and by 3. So the purpose of the formula is just to be able to have a quick way, I don't know why I put an equal sign there, a quick way to figure out for 12. 12 is the figure number, so I'm going to take out F and I'm going to put in 12. That's the purpose of the formula, is just to have a quick way to figure out the number of blocks without having to count them all. What's 3 times 12?
36.
What's 36 plus 1? Why did I do the multiplication before the addition? Bed mass. So what does this tell us? How many blocks are in the 12th figure? 37 of them. What figure would have 106 squares? What figure would have 106 squares? Well, I know it's way more than the 12th figure. How do I know that? 12 only has 37. Well, I'm going to use the formula again in order to find this, and it's a quick way to do it. This time I'm going to take out n, and I'm going to put in 106. Now I just want to solve for this f. This is an equation like you looked at in grade 8, and we're going to look at different ones this year, but it's built upon what you know from grade 8. How do you get rid of a plus 1 in an equation? What's the opposite of adding 1? So I'm going to subtract 1 from both sides. So what's 106 minus 1? How do I get rid of a coefficient of 3? Well, that's f times 3. What's the opposite of timesing 3? Dividing 3. This you could grab your calculator and do 105 divided by 3. Offer of 35. Just looking for confirmation. What is 35? What did I just figure out? So this is the 35th figure. We'll have 106 squares. All we're doing is looking at patterns and putting linear equations to them. Why? Because lines are that important that we need to start looking at them now. Questions so far? You're going to see every question is going to work this way. I'm just going to change the pattern. Here, I'm solving for f. I'm trying to get f by itself. Let's look at circles. Same questions. Describe the pattern in words, create a table of values, create the equation, and then it's going to ask us to do some calculations. Do we really care that it's circles, blocks, triangles? No, it's irrelevant. All we want to know is what are we adding from the first one to get the next one. So I start just by counting. The first obviously has one circle. How many circles in the next one? Followed by? Followed by? What do we add to the first figure to get the second? What do we add to the second figure to get the third? What do we add to the third figure to get the fourth? Part A, we start with one circle and then add 2 to the previous figure. Do you see how we answered that the same way as the last question? We just changed the numbers. Table of values. This time I'm not going to draw all the little lines because you don't have to, so I'm just showing you a different way to do table of values. If you like those dividing lines, put the dividing lines. If you're like, don't want to draw them, don't. The top is always going to be the figure number. The bottom is always going to be the number of objects. In this case, it's number of circles. Top is always the figure number. Bottom is always the number of objects. Figure 1, how many circles? Figure 2. Figure 3. Figure 4. Show me a couple more to make sure that I understand you know the pattern. What would figure 5 have? Figure 6, 11. And I noticed space, so I'll stop there. If you've got more space, great. So do you see how I didn't put those dividing lines between the numbers? Completely up to you how you want to do your table of values. Questions so far? C is creating that linear equation. It's always going to be number equals something times f plus or minus something. That's called a linear equation. N is the number of circles, f is the figure number. We just need to figure out the two numbers that we need to put in. Where does the number in front of f come from?
How much you go up.
How much we're going up by. How much are we adding every single time? 2. All I need to do now is figure out what do I need to add or subtract to get my second number. So if I put a 1 in here, I've got 2 times 1, which is, what do I do to make that 1? Subtract 1. And then I like to just double check with the next couple. If I put 2 times 2, we have 4 minus 1. 3 times 2, 6 minus 1. 4 times 2, 8 minus 1. 5 times 2, minus 1. Does everyone understand where we got the minus 1 from? That's the hardest part. Okay, so it's what do we need to add or subtract in order to make that first one a 1? D and E will always just be some kind of substitution question. You just have to figure out if I'm putting for F or putting for N. How many circles will the 71st figure have? Well, obviously, I do not want to write out those table of values for the first 71 figures. That's why we have these equations, to be able to quickly figure out how many blocks we have. Am I putting the N for 71 or am I putting the F for 71? How do we know it's F? because it's the figure number. So for D, n has to equal 2 times 71 minus 1. If you need your calc, go for it. Looking for an answer.
141.
That sounds confirmed at the same time. 141 what?
Circle.
Circles. He wants to know is which figure would have 83 circles. So am I replacing n or replacing f? Is 83 a number of circles or is it a figure number? So it's going to go on the left-hand side. What's the opposite of subtracting 1? Adding 1 to both sides. 83 plus 1. What's the opposite of timesing something by 2? Dividing it by 2.
42, sir.
42 what? What did I just find? 42nd figure. Now it says verify your solution, so just let me show you how to do this. If you're on the exam and you got extra time, you can verify that it is the 42nd. I'm going to go back to the equation, and I'm going to put in 42. And what should n be? So what are we checking over here? 83. It should be 83. If we've done our math correct, we should come out to be 83. So 2 times 42. 84 minus 1, 83. That's when it says verify your solution. That's what you're doing, just to double check to make sure the question's correct. Show me your thumb so far. Getting the pattern stuff, kind of getting it, not getting it. Put it really high so I can see. Awesome. Oh my God, no diagrams this time. Sometimes they're just going to give you a pattern in words, and question A is draw the pattern yourself. An orchestra seating is arranged in a rainbow shape. What's another word for a rainbow shape mathematically? Arc. So it's going like this, like a rainbow. Carter, what are you doing there? The first row, the innermost row, has 7, then we have 12, then we have 17, then we have 22. How would you like to draw this out? Where do you want to start? How many lines do I need to make for my rainbow?
4.
How many chairs need to go in the first inner row? 7. You could use dots, you could use squares. I just chose X's, but you can have them look like whatever you want. How many are in the second row?
4.
Third row? 17. And then 22. Why do orchestras put their seating in that arrangement? Not so much that they can hear better, but more important so they can see the conductor who stands in the middle. So everybody has view. Plus, this is the most aerodynamic for the sound, is always in kind of a curve. Do you understand what part A is asking when it says draw out the pattern? Table of values. This time I don't have a figure number. What do we have? What are we counting? 1, 2, 3, 4. That's not the same as the figure number. It's the row number or number of rows. First question, I had squares. Second question, I have circles. What do I have this time? Number of chairs. Okay, so first row, how many chairs did we draw? 7. Second row? Third row? Fourth row? And let's do the fifth and sixth to show that we know the pattern. So all we're doing is looking is what are we adding?
5.
So 22 plus 5. And then 27 plus 5. Right, the equation for the number of chairs in each row. Well, I can still use n for chairs. You could use c for chair. You could use whatever you want. I'm sticking with n for number. What do I know about the first number in my equation? It's got to be a 5 because it's always that number we're adding. Now, I probably don't want to use f because I don't have figures. What do I have? Rows. So I probably want to use an r to represent rows. And now I just need to figure out what do I add to get this first number. So what do I add to 5 in order to get 7? 2. Well, let's just double check, make sure that's correct. If I take the second row, 5 times 2 plus 2, 3 times 2 plus 2, 17, etc., etc. Use the equation to verify there are 22 chairs in the fourth row. So they have now told us the number of chairs. What do we do? How do we verify there's 22 in the fourth row? Put it in here and solve for n. Bed mass, what do we do first? 20. And then plus 2? 22. There we have used our equation to verify there are 22 chairs in the fourth row. How many chairs in the seventh row? Well, what am I replacing for 7? Am I replacing n or replacing 5? I'm replacing n. Really? Can't replace the 5. The 5's a number. R. I'm replacing R for 7. What do I do first, the multiplication or the addition? Multiplication, so 5 times 7. 35 plus 2. And just clarify 37 what? Squares, circles, triangles, chairs. Seats would be fine. Do you see how each question looks really similar to the previous question? That was it. You're going to open your text.